Hello guys, good evening and greetings to everybody. This is John again, live on our usual session. Today I want us to treat acid-base balance. What we are going to do here particularly will be related to the calculations, how we can calculate the acid-base balance. I know this area is somehow a difficult area for many nurses, whenever this topic ABG analysis is concerned. So many nurses, they shy away from this, even from nursing school. And I have talked about this topic over and over, and I did a small video. I want to do this one again, which I am going to share it on my usual YouTube video so that most of you can have it as a reference point. So I'm going to do a briefing on some steps on what you need to know in order to be able to figure out and do these calculations as easy as possible. And I'm going to treat some sample questions, okay? Let's get started. This is Mr. John from Abg Healthcare Consulting, and I'm doing this and will be posted under our usual YouTube channel, Nurses Corner. Okay, ABG analysis. So what we need to know, you have to know these values. You have to know the range of the pH values. Okay, I'm going to show you. You have to know this. The pH value, they range from 7.3 to 7.4. And it's easy to know the carbon dioxide. Just pick out the 35 year and the 45 year will give you the range of the carbon dioxide, which is 35 to 45. Then for the carbonate, I usually give this short form on how to memorize it. You can say 2 plus 2 plus 2 is equal to 6, which stands for 2226. Okay, you can also say 2226, meaning it ranges from 22 to 26, okay? Then we have our normal oxygen. We know that the Allen's test is the test used to obtain the arterial blood specimen, and it is done on the radial artery, okay? We want to determine the circulatory arterial blood in the system, and the test is called Allen test, and it is done on the radial artery. Okay, maybe you might have come across some questions of this nature. And now what is important for our class for today is on the calculation. So I'm going to give you some steps which we are going to follow, and we will have to see this. First, what we have to know is that in acidosis, the pH decreased, okay? The pH is decreased, okay? In alkalosis, the pH goes up. Now, coming back here, we have here, I have to erase just this. Yeah. Now, below 7.35 is acidosis, and above 7.45 is alkalosis. That's what we need to know. And that's why we're saying that for it to be an acidic situation, an acidic condition, the pH is decreased. And for it to be an alkalosis, the pH is elevated or increased. Now, we know that we are dealing with two important indicators, the respiratory and metabolic, okay? So the respiratory function indicator is carbon dioxide, carbon dioxide. So when you have a situation, a question where for the answer to be able to be a respiratory condition, your focus should be on carbon dioxide. For it to be metabolic, your focus should be on the bicarbonate, okay, on bicarbonate. So all of this will be in relation to the pH, in relation to the pH. So when you have a question, the first thing you have to do, step one, let's look at it. Look at the pH. Now you look at the value of the pH. Is it elevated or decreased? If the pH is elevated, then it is alkalosis, just like what I said before. If the pH is elevated, meaning it's above 7.45, or on the higher side, we're going to see when we're talking about compensation, then it is alkalosis. If the pH is decreased, meaning it is below 7.35, then it reflects acidosis. You look at that, you take note of that. Then you move to step two. Look at the carbon dioxide. Carbon dioxide, we say it is the respiratory function indicator, okay? Look at the carbon dioxide. Is the carbon dioxide elevated or decreased? If the carbon dioxide reflects an opposite relationship, we are going to say that when we use the formula of Rome. Opposite means if the carbon dioxide, they are in different direction, meaning the pH is going high and then the carbon dioxide is going low, right? Therefore, it is a respiratory condition, okay? It is a respiratory imbalance. If the carbon dioxide does not reflect an opposite, if they are not in opposite direction, either pH is going up, carbon dioxide going down, or pH is going down and carbon dioxide going up, move to step three. It means it is not a respiratory imbalance. Move to step three. Step three says, look at the carbonate. The carbonate is the metabolic function indicator, right? You look at it. Does the carbonate reflect a corresponding relationship with the pH? Meaning, are they in the same direction? Direction means, are they all increasing or they are all decreasing? It doesn't mean they have to have the same value, okay? If it does, then the condition is metabolic imbalance. Step 1 to 3, look at the pH. Step 2, look at the carbon dioxide. Step 3, look at the carbonate. And step 4, this way talk about compensation. You will hear words like full compensation or compensated or partial compensation or incomplete compensation. Now, for full compensation to occur, the pH has to be in the normal range of 7.3 to 7.4. Get it? For the condition to be compensated or full compensation, the pH has to be within the normal range of 7.3 to 7.4. If the pH falls out of the normal range, if it's not within the normal range, you look at respiratory or metabolic function indicator, okay? It should be either a respiratory imbalance or a metabolic imbalance. And that's where we will say it is uncompensated. Uncompensated means the pH is out of the normal range. It's either below 7.35 or it is above 7.35. It is, you hear words of partially compensated or uncompensated. Again, if the pH is between the normal range, it is compensated. Now, I have this acronym here, which we use. This it here is called ROM. ROM means respiratory opposite metabolic equal. What does this mean? Just like I explained before, you have to compare the values that you have. For it to be a respiratory condition, it means the carbon dioxide, which is the function indicator of for it to be a respiratory condition, has to be opposite. Opposite to what? To the pH. You are comparing to the pH. Okay, it means the pH should be either high and the carbon dioxide low, or the carbon dioxide is high and the pH is low. Either it has to be for it to be respiratory. For it to be metabolic, they have to be equal. Equal doesn't mean they have to have equal value. Equal means they should be going to the same direction. Either the carbonate, which is the function indicator for metabolic, should be increasing while the pH is also increasing. Or if the pH is decreasing, the carbon dioxide is also decreasing for it to be metabolic. Okay, that is it. That is very simple. You follow the steps, you'll be able to not miss a question on this. Let's look at sample question. I want this video to be as short as possible. Okay, review questions number 1. We have it here. Now, this is a question for you. The nurse reviews the arterial blood gas result of a client and notes that the following pH 7.45, carbon dioxide is 30, carbonate is 20. The nurse analyzes this result as indicating which condition. Good. First, step number 1. Step number 1, look at the pH. Okay, look at the pH. The pH is 7.45. Okay. Now, is it alkalosis or acidosis? Okay, you have to look at it. Now, you want to say it is not above 7.5 for it to be alkalosis, but it is on the more of the alkaline side because this is a continuum, right? It is more on the alkaline side. We are going to see why it is 7.45. So in this case, it cannot be acidosis. It is alkalosis. Write it down and keep. Okay. Alkalosis. Yeah, you keep. Now, step number 2, come back here. We have look at it. Is the pH elevated or decreased? If it is elevated, it is alkalosis. But we say it is more on the alkaline side, right? It cannot be because it's not this way. It is more this way. So it's alkalosis. Good, we got that. Point number 2 says, look at the carbon dioxide. Let's go back to our question. The carbon dioxide is 30. For it to be a respiratory problem, we say what? Our room. It means respiratory opposite. It means it has to be opposite. Is it opposite? Let's look. Opposite means when pH is high, carbon dioxide should be low. What is the range for carbon dioxide? Go back here. Carbon dioxide says 35 to 45. And our carbon dioxide is 30, means it is low, right? So what happened? They are in the opposite direction. So this formula holds for them, right? This formula holds this one, room. So this is a respiratory condition because carbon dioxide is 30. Look here, this value and this value, 30 and 45, right? They are opposite. pH is high, carbon dioxide is low. So that is a respiratory condition. So what do? Put it down, write it here, that respiratory. We say respiratory. Now, what do you have? You have respiratory alkalosis. Now, what is love? Let's look at compensation. Compensation says for it to be compensated, the pH has to be within normal range. What is our pH? 7.35 to 7.45. Yes. And our pH in the question is 7.45, which is within normal range. So our answer is respiratory alkalosis compensated, right? Compensated, which is B. This is our answer. Is that right? Did we get that correct? That is our answer. That is our answer. Yep. So let's move to question number 2. I hope this is clear. Okay, good. Question number 2 says, the nurse reviews the blood gas result of a client with atelectasis. The nurse analyzes the result and determines that the client is experiencing respiratory acidosis, which result validates the result findings. Now, in this question, they have given you the medical condition, right? That it is respiratory acidosis. Now, they want you to find out the values that suit that for it to be a respiratory acidosis. So you have to flip our formula to understand and find the values that suit. So we going back to our formula that says Rome. Okay, write it down. Rome says for it to be respiratory means the carbon dioxide, which is our indicator for respiratory. So our focus now is on pH and carbon dioxide. Take note. Our focus is on pH and carbon dioxide. Yeah. In this case, forget about metabolic. So for it to be respiratory, pH and carbon dioxide have to be in opposite direction. Now it's already acidosis, very simple. So the pH has to be below 3.5. So let's look which first pH, which one has pH of 3.5, below 3.5. This is it, right? This below 3.5. This one is within. Here is also on the acid side. This one is 7.50. This one is 7.52. It cannot be C and D. It is between A and B, but this one is below. Let's look at it. There is something that will tell us if it is actually that or not. Now, pH is low, of course, for acidosis. So we have to choose the one that has a high carbon dioxide. pH is low. Carbon dioxide has to be high. Okay, opposite, respiratory opposite. This one, this respiratory opposite. So now we have identified acidosis. It is acidosis, means the pH has to be low. This is it, we've gotten that. Our carbon dioxide now has to be high. So we look between B and A. Which one has a higher carbon dioxide? This is 50, this is 40. 40 is within normal range, it's not high. So because we say our carbon dioxide ranges from 35 to 45, right? So the right one here is 50. 50 is above 45. So a respiratory acidosis, our answer is A. This is the right answer. Okay. This is the right answer. Right? Correct. I hope this is understood. Now, let's move to the third question. The third question. This is very simple, right? Just practice more of these questions and you'll be fine. Okay, let's go. How many minutes now? Let's see. Okay. Let's go. Question number 3. A client who is found unresponsive has arterial blood gases drawn and the results indicate that the following pH is 7.12, carbon dioxide is 90, and carbonate is 22. And carbonate is here, 3. Carbonate is 22. The nurse interprets the result as indicating which condition. Okay. They say A, metabolic acidosis with compensation, respiratory acidosis with compensation, metabolic. Okay, let's start. Step number 1, identify the pH. Okay, that is it. That is the formula. Step number 1. Our pH says 7.12. So what's the range of our pH? Our pH ranges from 7.35 to 7.45. So this is what? This is acidosis. Write it down. Write it somewhere here. Acidosis. Good. Keep it there. Acidosis. Next step number 2. Look at the carbon dioxide. Okay? Look at the carbon dioxide. Is it elevated? If it is elevated, right, you have to look at it. We can just leave step 2 and go to Rome. Rome is very simple to apply in this case. Rome is very simple to apply in this case. Respiratory, opposite, metabolic, equal. So we have our respiratory is low, very low. Our carbon dioxide, for it to be a respiratory condition, should be high. Is it true? Carbon dioxide is 90, very high, very high. Okay, so this is a respiratory acidosis condition. Carbon dioxide is 90. So this formula holds, this one, respiratory opposite. So we come here and we say, no, not this. So we say this is respiratory acidosis. Okay, let's just try something to see if it is metabolic. Our formula for metabolic says, it has to be equal. Equal means in the same direction. Okay, we have carbonate is 22. It's down, it's low, not actually low, it's within the range, but on the low side. Okay, and the pH is low. They are equal. Okay, they are equal. They have to be equal, right? They have to be equal. Now let's look, but which one is actually, this is within, we can say it's within normal range. It's not low because carbon dioxide is very clear. It's very high. It's very high. Carbon dioxide is very high, so it cannot be metabolic. This one is within normal range. If the carbon dioxide was low, we can say, okay, it's on the lower side, right? This is very clear. We cannot even dispute that. Okay, now, so that it doesn't hold. We look at, for it to be compensated, we say the pH has to be within the normal range. Okay, you have to be careful. Such question will trick you. You will say, "Oh, sir, but carbonate is low. It's low. Yeah, it's on the lower side." No, you have to look. Yeah, but it is within the normal range. But the carbon dioxide is very clear. Okay, these questions can be very trickish. You have to be very careful. You have to be very careful. Yeah. So we say pH, for it to be compensated, the pH has to be within normal range. But our pH is 7.12, which is not within normal range. So this condition is respiratory acidosis without compensation. Yeah, without compensation. Without compensation. Yep. So the answer is D. Okay, this is our answer. D. Okay, guys, this answer is respiratory acidosis without compensation. That is the right answer. Okay, with this, we've come to the end of this short class. Again, remember, the pH 7.3 to 7.45, the carbon dioxide is 35 to 45, the carbonate is 2 plus 2 plus 2, which is equal to 6, so it's 22 to 26. And step number 1, always identify the pH first and keep if it is acidosis or alkalosis. Step number 2, look at the carbon dioxide. It should be in opposite relation, then it is respiratory acidosis. Step number 3, look at the carbonate. There should be corresponding relationship. They should be in equal direction for it to be metabolic. And in summary, always where the steps cannot go, always apply the formula room. The mnemonic room is very easy to find. And the fourth, for it to be compensatory, the pH has to be within normal range of 7.35 to 7.45. If it is not within normal range, then it is not compensated. It's either you see words like partial compensation, uncompensation, or incomplete compensation, whichever is correct. Okay, full compensation means compensated. You see words like that. Without much ado, thank you so much. Thank you so much. So we are at the end of this class, and see you. Please subscribe to our YouTube channel, comment, share our videos. We hope to post more for you guys. And if you think the content is good, share with your friends, comment, like the page, and tell us which topic you want me to do, okay? Which topic you want me to do, okay? See you guys. Bye-bye.